In previous lecture, we have seen the information regarding old quality tools. So there are 7 old quality tools. Out of those 7 old quality tools, in the last session we have seen the quality tools like check sheets, flowcharts, histogram, and parrot chart. So 4 old quality tools we have discussed in the last lecture. So the purpose of each check sheet and purpose of each quality tool and its benefits we have discussed. How it is presented, that is also seen. Then this is a parrot chart. Now moving further, the next quality tool is a cause and effect diagram. It is also called as a say fishbone diagram. So basically the purpose of this cause and effect diagram is to study how an unaccepted part is produced or how a defective part is produced. So we want to find out the reason behind the production of defective or unaccepted part. So this is a outline of a cause and effect diagram. This also called as a fishbone diagram because it looks like the fishbone. That's why it is also called as a fishbone diagram. So this is the outline of this fishbone diagram. So whenever a defective part is produced, it is essential to analyze the production process because we want to identify the cause of production of such part, because we need to take the corrective action, otherwise such type of the defective parts will get produced and it will be the loss to the company or organization. So this can be done with the help of this cause and effect diagram, which is shown in this particular sketch. So defects in any production method or production are mainly due to the factors like man, machine, material, method, and environment. These are the few say parameters which are responsible for production of defective part. There may be one reason or there may be combination of reasons, so it is necessary to find out the exact reason behind production of defective part. So how this is worked out? So first in this study, all these elements, that is man, machine, material, method, these are say listed, and factors causing the defect related to each of these elements are studied one after another. So now let us see what are the steps involved in this. We will elaborate our statement. So the various steps involved in preparing this CE diagram, that is cause and effect diagram. So first step is you have to define the problem. So here is the problem, you can see problem or effect. So here you have to define the problem, nature of the problem. What is the exact nature of the problem, that you have to define here. Okay, and you have to put it at the center and draw one horizontal line. So at the end of this arrow you have to write down the problem. Then select the method of analysis. So you just uncover the cause of the defect. So it may involve use of other tools, like you can use the Pareto diagram, you can use the frequency curve, you can use the histogram. So with the help of the other quality tools which you have used for the data collection, which you have used for the analysis, those can be used, and with the help of those say tools like histogram and frequency curve, Pareto diagram, you can find out the cause of the cause of the defect. Okay. uh, so here uh, you can get the inputs from other departments like inspection, design engineering department, material department. These departments can also give the input whenever you are analyzing your problem. Okay. So you draw the problem base and center arrow. So this is the problem base and this is the center arrow that you have drawn. Then specify the major categories of possible sources contributing to the problems. So once we have uh, chalked down the problem or effect, we will try to find out the major categories of possible sources contributing to the problem. So we know that man, machine, material, method, these are the major categories which are going to contribute towards the problem, isn't it? So those are written here: man, machine, material, method. Then identify the possible causes of the problem. So you can see here, this is a primary cause: man, machine, material, method. Then there is a one secondary cause that is written as a cause. Okay. So you try to find out the possible cause, what may be the possible cause of the problem. Okay. Then after that there are sub causes also. So analyze the problem, you write down the sub causes also, causes, sub causes, all you have to write down everywhere. For each major category you are going to write cause, sub cause, sub cause, if it is applicable. Okay. And you analyze the situation, you analyze you tackle the situation one by one, go on asking the question, go on verifying the various possibilities, and try to find out the root cause. Okay. And once you analyze this problem, you have to suggest the corrective action. So that's how the cause and effect diagram works. So many times this is used as one of the best tool to find out the corrective action. So many times this question is asked in the examination. So please prepare this as an important question. Then again, as I told you, this is last was the just skeleton. Now this is the example of the fishbone diagram. You can see one problem statement is there, that is a blurry photo. So someone has clicked a photograph, someone has clicked a picture, but whatever picture is clicked, that is a blur. So it is not clear picture. We know what is the meaning of blur. Okay. So why this photo, why the picture or photo clicked by a particular person is blur? Okay. So there may be different. So this is our problem statement. Blurry photo is the problem statement. So for this blurry statement, what can be the reason of the blurry statement? So there are say various possibilities are there. So there may be problem in the hardware, there may be problem in the method, there may be problem in the user, there may be the problem in the environment. So these are the major categories which because of which the photo is blurry. Now you have to go on say analyzing the problem. So you have to check each possibility. For example, if you are say for environment, the subject, whether you have to check whether the subject is moving too fast. So now you have to analyze whether now you have to ask the question, is the subject moving too fast? If the answer is yes, that can be the question, that can be the solution. Okay. So if the answer is no, subject is not moving too fast, then this option is not there, so remove that. Then is the ambient or is the environment too dark? You have to check whether it is too dark. If it is not too dark, means that is not also the root cause. Then you go for the other say major category, that is a hardware. So in the hardware of that photographed say device, you have to check whether the lens is a dirty. Check it, get the answer. Is if it is dirty, say it can be clean. If it is not dirty, it may be the wrong lens, resolution may be less. So check whether the lens of correct specification is used or not. Then if both are not there, go for the next category, method. Check the whether you have used the wrong method. Check whether it is out of focus or wrong exposure. So each and every possibility which can cause the blurry photo is say explored and try to find out the root cause. Similarly, user not following the instruction. So it may happen that user is not following the instruction. He has the shaky hands, so he is not able to stabilize the image. So likewise, the out say you can see for a blurry photo how many possibilities are there. 9 possibilities are there. So out of the 9 possibilities, you have to find out the correct reason for a blurry photo. So this is very useful method for finding out the root cause of a problem. Then so as I told you, steps in say the steps in cause and effect program. So we have already discussed these steps. Then there is another quality tool that is called as a scatter diagram. So what is a scatter diagram? Scatter diagram is a mathematical approach to study the correlation between factors that are suspected to be related to each other. Okay, so this is very important when you are studying any kind of say experiment. If you are doing any kind of experiment, you are trying to find out the relation between various factors so that you can interpret a particular phenomena. So you are trying to study the correlation between various factors that are suspected to be related to each other. So you want to find out whether there is a relation between various factors, isn't it? For example, if you take the expansion of the say mercury in a thermometer and the input temperature, so there is a strong relation between the temperature and the expansion of the mercury in thermometer. So as the input temperature increases, the mercury in the thermometer is going to expand in that proportion. So there is a strong relationship. So similarly, we have to find out the relationship between various factors in a particular phenomena which may be related to one another. Okay, so it is used to study the relationship between a performance characteristics. So we may call it as a output. Performance characteristics can be considered as a output, or it can be considered as a effect and a factor, or you can call it as a driven factor and a factor responsible to cause this performance. So factor responsible to cause this performance means it is nothing but it is the input, or you can call it as a driving factor. Okay, so here there are two factors are there. One is a driving factor, another is a driven factor. So driving factor is your input, driven factor is output, or you can say driving factor is your cause and driven factor is performance. Okay, so you want to study the relation between these two factors, driving and driven factors. Then number of observations are taken and plotted. Actually number of you cannot interpret the relation between various variables with very few readings. A large amount of data will be required to interpret the relationship. So fair amount of data is must, and that has to be taken and plotted. Now in how the what you can say, how the relationship is interpreted. So we can see there are various possibilities. Scatter diagram, this is a y-axis, suppose this is a x-axis. On y-axis there is a performance characteristics, on x-axis there is a driving factor or cause. So here on y-axis there is effect, on x-axis there is a cause. Okay, so as you can see, there are three sketches are there. So sketch number 1, sketch number 2, sketch number 3. So in sketch number 1, as you can see, as the variable on x-axis increases, okay, the variable in y-axis, variable on y-axis also increases. You can see there is a, you can say, as x increases, y also increases, isn't it? And all are very close to one another. That's why you can say there is a positive correlation. There is a positive correlation. So what is the meaning of positive correlation? The meaning of positive correlation is that an increase in the driving factor. So whatever you are plotting on x-axis, that is a driving factor. So increase in driving factor on x-axis increases the it causes increase in the performance characteristics. So performance characteristics is on y-axis. So in as an increase in driving factor causes an increase in the performance characteristics and vice versa. Okay, so this is called as a positive correlation. Then there is a negative correlation. So exactly opposite to the positive correlation, increase in the driving factor causes decrease in the performance characteristics. Exactly opposite to this. So as x increases, y decreases. Okay, so negative correlation, opposite side correlation. Third, as you can see, the dots are scattered all around the say places. That's why we can say that there is no correlation at all. Sometimes it may happen that there is no relation between two parameters. Okay, so that is called as a no correlation. So as you can see, positive correlation, increase in x causes increase in y. Negative correlation, increase in x, that causes a decrease in y. No correlation, so there is a no relationship between two variables which were suspected to be each other, but no such evidence has been recorded or observed. That's why there is a no correlation. So this is called as a scatter this is scatter diagram, and these are the interpretation of the results. So we can further say take analyze this interpretation. This is a variable b, again this is variable a. So we have seen that there is an increase in x, as there is increase in x, increase in y. So there is one more classification, that is it is a positive, but it is a strong positive. You can see it is a strong positive because all the parameters, so all the points which are mentioned over here or which are shown over here, they are very close to one another. They are close to one another. That's why it is a strong, there is a strong correlation because they are very close to one another, isn't it? So it is a strong as well as positive relation because increase in x, increase in y, and they are close to one another also. So strong positive. If you compare it with this sketch, it is called as a weak positive because increase in x, there is an increase in y, there is no doubt. Okay, that's why it is a positive. But why it is weak? It is weak because this, whatever these points are there which are plotted over here, they are not close to one, they are not enough close to one another. That's why it is a weak positive. Okay, it is a weak positive correlation. Then coming to this part now, it is a, as we can see, it is variable a, variable a, variable b, variable a. So as a increases, b goes on decreasing, isn't it? As a increases, b decreases. So it is a negative correlation, but it is a strong negative correlation, because again, as discussed here also, these points, whatever these points plotted, they are close to one another. That's why it is a strong negative correlation. Okay, whereas here, coming to this sketch now, variable a, variable b. So as a increases, b decreases. So it is a negative, but it is a weak negative, because there is not close, so these points are not enough close to one another. That's why it is a weak negative correlation. Okay, so then uh, last correlation is a, this is we have already studied. There is a no correlation between various parameters at all. You cannot interpret, you cannot correlate variable a and variable b, isn't it? So there is no point to study the correlation between such factors at the time of the experimentation. Okay, so whatever we have discussed, that is written over here, so no need to study this. Then control charts. So control chart is a very famous quality control tool which is widely used in industries. It is very widely used in industries. So the control chart is specially used in SQC, that is a statistical quality control. It helps to decide whether the process, whether the ongoing process is under control, or it is also used to decide whether the process has capacity to meet the specified tolerances. So that is that's why SQC is a very important tool, because everybody is interested in finding out whether the process is in control or not. Okay, and also every organization is interested whether the organization can meet the specified tolerances required by a particular component or particular product. So it is like a feasibility study. You are checking the feasibility of your manufacturing process. Okay, so before accepting any order, you have to do this. You have to check the capacity. You have to check the capacity of your plant, not in terms of the manufacturing tonnage. It is in the form of the quality of the product. Okay, so control charts, we are going to discuss all these control charts in detail. Unit number 5. So as you can see, in any control chart there are basically two limits are there. So as you can see, one on axis there is a time, and variable on y axis there is a variable. This one central line is there, that is in bold, and two dotted lines, one above the center line, okay, and one below the center line. So one dotted line, another dotted line. So one dotted line corresponds to upper control limit, another dotted line corresponds to lower control limit. Okay, so then now why the control charts are to be used? Because in any manufacturing process, variation in the characteristics of the product is going to be always there. You cannot produce the components of exact size every time. In mass production, you cannot produce the you cannot produce alike components. You cannot produce the component whose dimensions are every time the dimensions are same. Suppose your objective is to turn a shaft, turn 100 shafts whose diameter is a 30 mm. So you cannot every time produce the shaft whose dimension is exactly 30 mm. There is going to be some kind of variation is always going to be there, because n number of parameters are there which will cause the variation in the size of that shaft, which so some of the variations will be in your control, some of the variations will not be in your control. So some amount of variation is always permitted. Remember this word, some amount of variation is always permitted in any manufacturing process. Okay, so that variation, allowed variation, is nothing but it is called as a tolerance. So we have already learned the tolerance. It is the difference between the upper control limit and lower control limit. So this dotted line shows the upper control limit, this line shows the lower control limit, and whatever characteristics which is being measured, that you have to plot. Suppose you are taking the, say, if you are finding out, let us say, hardness of various components, so you have to just write down the your target, what should be the hardness, and then what is the upper control limit, what is the lower control limit. Suppose the hardness, required hardness is 180 bhn and the tolerance given is a plus minus 10 bhn. So 180 plus 10 bhn means upper control limit is 180 plus 10, that is 190 bhn. The lower control limit will be 180 minus 10, that is 170 bhn, isn't it? So lower control limit is 170 bhn, upper control is 190 bhn. So whenever you are checking the actual hardness of a component, so whatever value is there, that you have to mention. That scale will be provided here. Suppose if you check the first hardness of the first component and that value is, say, 173 bhn, so you have plotted it here. This is 180 bhn, so 173. Then second component, say, 182, third component 180, fourth component 185, sixth component 172, 180, like that. Okay, so all the observations that you are getting, you have to go on plotting those points in this control chart, so that you can get the idea that all the variations, so these are the variations, say right from 170 to, say, 180, some one of the component has hardness, say, which is beyond upper control limit also, isn't it? So it may be around 193 bhn, let us say. So it is going outside this upper control limit, so this is also open. So you can say the variation in the hardness is right from 170 to 193, 21 bhn tolerance, variation is there. Okay, now with the help of the this quality control, we can find out whether whatever process is going on, whether it is going as per the plan or not. That can be easily understood. So up to this, you can see, up to this the variation is okay, but here one part has gone out of the control, isn't it? That's why the process is not under control, because this point is going outside these control limits. So you have to take the corrective action. Why this has happened, isn't it? If the process is under control, there is no issue. You are say confident that your process is under control. But once if the observation or the measurement is going outside the control limit, it means that is a cause of there is a reason to worry, and you have to take the correct action. This is not acceptable. Okay, now variations in the process are because of the two causes. Variation is there, but there are causes for the variation. There are two types of the causes: assignable causes and non-assignable causes, or you can call as a random causes. Okay, if the variation in the process, okay, if the variation in the process is because of the random causes or common causes, you can say that the process is under control. It is observed that many times it is observed that whenever the process is under control, whatever variation is there, that is because of the random variables or common causes only. But if the variation in the process is because of, say, assignable cause, because of the assignable cause, so this here you have to take the corrective action. For this much variation from here to here, you don't have to take any corrective action because it is acceptable. But here you have to take the corrective action because this variation is because of the assignable cause, or it is called as a special cause is there. Something wrong is happened which should not be happen. Okay, so you have to find out that reason and you have to take the corrective action here. Okay, so that is the control chart. That's why detection and elimination of assignable cause. So detection of the and elimination of assignable cause, it leads to substantial improvement in the quality of the products. Okay, so this control charts entire, we are going to see these control charts in detail afterwards in the unit number 5. So with this we have seen the various old quality tools, that is 7 old quality tools. Many times this question is asked in the exam, that is a what are the 7 old quality tools, mention that and explain any two, or they may give you a special any kind of this tool can be asked to be explained. So that can be asked by the examiner. So you should be able to write these various say quality. It can be anything. Out of these 7 tools you can be asked anyone. Out of these 7 tools you can be asked anyone in the say always there is a one question, last question is there, in that this might be asked. So write a short note on check sheet or flow chart, histogram or parity chart, cause and effect diagram, scatter diagram, control charts. So you have to study this in detail, and this is the favorite question of the students. Okay, so we'll stop here.